No, that stinks. Thanks for the offer. I'm putting it on anyways, because I know it's all dry, I think.
Yeah, it's real.
It shouldn't be spotted like that.
It's real, I swear. Next.
Oh, sorry.
We're good.
I also don't like the fact that we're singing in space. Ah!
All right, guys. Before we get started, are there any questions on we've already covered basic on the basics? No.
Yeah.
I want this to mostly be a work day. Then I wanted to just briefly go over a couple of ideas, just kind of basic ideas. So. This is a bit of like a warm up, maybe. Let's just pick one of these. Evaluate the curve thing. Maybe. I don't know. Maybe like 4C could be good, or.
I'm down.
Or 4E, maybe 4E. 4E is kind of interesting.
Why do we have to graph
Let's do
these?
4E. What?
Why do we have to graph these?
You don't have to do anything. Right,
Why do
Emily?
you want us to graph these? I can't think of how to graph that on the top of my head.
I get what you're saying, but I don't agree with that analysis. You know, you can have no free will, but still. To say there's no free will is not to say that you never choose anything. You make choices.
But the choice.
It's not fully deterministic. It's just
Decided on the date, Jesse.
like we do live in a society. Let's give you an example. I
It just
love
had to be on that day to get it.
what?
When you're talking about free will versus like determinism, it's not necessarily like one is absolute, but there's a statistical analysis of the
Tell Aaron to solve. Maybe. Here's a simple example. I love donuts.
They're not that, yeah.
That's true. I actually do love donuts. They're bad for you. They're really bad.
Yes, not everybody's.
When I pass by the donut box in the store, I can make a choice to buy the donut or not buy the donut. Okay, but can I decide to no longer crave donuts? No. Can I just be? I'm the kind of person who I don't even want the donut. I want a nice celery sandwich.
Celery sandwich.
Right? Like, no, I can't choose that. Now, also, when I actually do make that decision of buying a donut, that's where it gets interesting is when I do make that decision, how much control do I have over that decision to not have the donut or to have the donut? That's where maybe, I'd always recommend Robert Sapolsky's book, Behave. It's very, especially the second half, it's very interesting. Gets into those minor details. But
Yeah, free will doesn't include like actual like physical. Which is that your main thing? Like, I'm trying to buy the
I'm saying when people say, first of all, when I say that free will doesn't exist, I'm like partially joking. But I do recognize a lot of academics would argue, make a hard argument that no, there's no free will. Because every decision we make is ultimately a result of genetic and environmental factors that have led you up to that choice.
Because like the donut, like it's that example.
I want a donut.
Donut.
What?
And
Can
then
I go
depending
get
on the
myself a
ulterior factors, there's another
No.
chemical that impacts like that impulse.
Maybe tomorrow.
Which one wins?
Yeah, so and so when I don't have the donut, when I make the decision to not have the donut, I make a post hoc rationalization of how I have really good willpower. Yeah, I'm a great guy. Like, wow, just pat myself in the back. Like, that's because I have strong willpower. But really, there are probably other factors that led me to that decision. So, anyway, so I don't think anyone's out there arguing that everything is just fully deterministic. Like, you're. But maybe if you look at it at some atomic level, maybe you could say it. I don't know. Anyway, sorry.
Yeah, I don't think people are.
Shout out to Griffin.
Yeah, I don't think people are arguing that it's like predetermined. Like I can tell you what's happening now. That's determined. but I think it's like predictable based on like the different ways your body works. Because biology works off statistics.
Oh.
No,
the
not
most
that.
salient example to me is always, oh, I'm just gonna choose right now, I'm gonna make a decision to be a more patient person. Is that possible? I mean, maybe. For me, it is not. Empirically, it is not proven to be possible. Even though I've tried very hard, all I can do is I can suppress when I'm feeling those very impatient, those emotions that are generated by frustration, being impatient, and I can just bottle them up inside, but I can't just not feel them.
Yeah.
Yes, I really can't not feel impatient right
63,
now.
no, because 32 is a power of 2, and 63 does not have a factor of 2. Okay, so sorry. So anyway, shout out to Griffin. Sorry for
He didn't have time to give one.
dumb and boring. Okay, so I said we'd go over like 4E, quick little jogger memories. So it says, what is the integral from 1 to 3 of this weird? Now, I'm gonna rewrite it. I hope it's okay with you.
Oh, E.
Yeah, E.
I thought you said C, therefore
All right.
I'm confused.
Of course, we want to rewrite it that way because we are always looking for, can our integral be written as in the form u prime times u to the n dx, right? So if the thing can be written like this, then the integral would be u to the n plus 1 over n plus 1. It's constant. Make sense? Does he be like that?
Yes.
Yes. Poggers. Okay. So this right here is the u, and you're kind of like, oh, it's already a u prime. I don't have to worry about like multiplying them and dividing or anything. It's already there. He's already there. That's good. So the answer to this, or at least the integral result, would be u. So maybe in the margin I go, well, this is going to become u to the -1 over -1, right? Yes? So this would be negative x squared plus 1 to the -1. Is everyone okay with that? And then the evaluation is from 1 to 3. Maybe an intermediate step, because that's maybe a little bit confusing to look at. It's -1 over the quantity x squared plus 1. Evaluated plus 1. All right, are we sure? We're super duper positive there's no questions in any of this. No plus C, because remember, if I did have a plus C, it would just end up canceling out anyway.
Yeah.
So what we tend to do is just not include it in this. Not that it would be like, I mean, I hesitate to use the word wrong. It'd be very unusual to have a plus C in there. So does that make sense? So the question is just what's the integral of this? You got a plus C, but if it's a definite integral, meaning there's the two bounds, then you omit. Okay, so let's plug in. Plug in the 3. What do you get when you plug the 3? -110 minus -1/2. So that's really a plus. So it's a half, a positive half, right? Or 5/10.
4/10.
So 4/10, yes, which is 2/5. Are there any questions? Well, how about graphing it? Which is a graph representation. What did we just calculate?
How much area is it?
A little bit of, yeah, we just calculated an area. So another little exercise in graphing functions. Okay. Does he have any asthma-popes? No asthma-popes? Can someone name like a noteworthy point on this graph?
0, 0.
0, 0, very good. It's got the origin, right? If you plug in 0, you get 0. And what kind of end behavior does this thing have? What would he approach? It's got to approach 0. So the right half looks something like this, right? Because it has to go up, right? If x is positive, then y is positive. So it has to go up and then eventually decrease. Now how about on the left side? If x is negative, what kind of values do you have? So, well, we were just looking at the area from 1 to 3. So whatever that would look like, maybe it looks like this. It's not a very tall function, because as we saw, the area from 1 to 3 was only 2/5. Right? Oh, here's a fun question. This might tax your brain a little bit. If you're brave, can anyone guess what is the average y value of the function between 1 and 3 based on this result? This is a tricky one. The average y value. What? Very close. 1/5. 1/5's the answer. Because the base of this shape is 2. 2 times what would give me the area. So there's this idea of like, this is actually something we're going to cover later. It's actually the next problem set, but so just something to think ahead towards is, yeah, the average y value in there would be 1/5. Does that make sense? So well done, Alyssa, for throwing out the 2/5. That's you're certainly on the right track there. Okay, so let's go over one of these on 5. Think graphically / geometrically. Think graphically geometrically.
That's gonna be hard because that's not how I think.
Just for you, Jason. That exclamation point is just for you.
Yay.
What's wrong, Lillian? Nothing? You're gonna be okay over there?
Yeah, great. What are you talking about?
Okay. Okie dokie. A couple in here have very fascinating results. Very, very fascinating results. Let's start off with sort of an easier one. The first one. This what's the integral of this absolute value function between -4 and 6? So that raises a question. Do we have a method for integrating an absolute value function?
No idea.
Mr. Paul.
I have no idea.
I don't know. Absolute value things confuse me.
No, it's not something we've covered, right? We've not talked about, unless you want to break it into a piecewise function, right? You can maybe talk about integrating them separately, but no, we have not talked about derivatives of, we've not yet talked about a function whose derivative is an absolute value function, right? So, so what do we have to do?
You have to figure out how to do it.
Thank you, Alyssa.
So
You want to split the part?
let's look at the area. So we're going to think graphically / geometrically. That's the key. So that's the key, is we're going to think graphically. So let's think graphically. Let's graph this function.
Well,
We know what the graph looks like, right?
yeah.
And we know that integrals correspond to areas. So what if instead of calculating the area, we just find the area geometrically? That should be the answer, right? So let's go from, so just gotta be a little careful here. There's -4, here's 6. Okay, how tall is this triangle, by the way? It's 4, right? And how tall is this triangle? Okay, so let's get some area here. So like Trey said, it's going to be 1/2 times 4 times 4. So this triangle here is, so it's just 1/2. It's going to be 8. Plus this area here. Like, is any of this area below the x-axis? No, it's all positive. Okay. This one's going to be 1/2 times 6 times 6. So it's going to be 8 plus 18. That's right. 26. There you go. There's the answer. How do we feel? How are our feelings about that?
I'm presuming it's gonna be a lot more challenging.
Really? I mean,
You just have to break it up into different sections.
well, let's look at C, the one right below. What's wrong, Trenton? What's wrong?
Yes. My mood.
Let's do D. D is more interesting, actually. Let's do D.
Okay.
Okay.
No, stop breaking.
This is a good one. This one's really
Oh, is
interesting.
this the one that's like wee? Yes, Jesse. Wee. I like this one.
Okay. When you look at that, you might, you learn about integrals. It's very natural to go, well, I'm going to think of that as my u, right? So what's u prime? Negative 2x, but I don't see any x out there. So you're kind of like, I'm really in rough shape here. There's not much I can do, right? I'm just kind of stuck. So it turns out for this one, you go, well, who feels brave and wants to throw out what shape this is describing? Brave?
It's like the curve where it like touches at the. So it's like
Oh, it's
Dylan
this
got
way.
it.
It's a
Dylan, well done.
semicircle.
It's a
Right?
semicircle.
It's a semicircle.
Okay, so remember, guys, quick little review here. This is going to come up a few times. So remember, guys, a circle is x squared plus y squared equals r squared. If you solve for y, like say you're trying to turn it into a function, you would get plus or minus the square root of r squared minus x squared if you just rearrange the formula, right? But that would be, the plus is the top of the circle and the minus is the bottom of the circle. So if you don't have the plus or minus, then it's just describing the top of the circle. Do you feel okay about that? Makes sense. A rhombus. Are there any questions on that? No? Yes? Makes sense? Okay, so what I'm gonna do is think graphically and geometrically. What's the radius of this semicircle?
2.
2.
Do you actually know what a rhombus is?
I think I do.
Is the square that's like shifted?
It's a diamond.
Today in AP calculus, what's a rhombus?
I guess I should.
It's the diamond.
Okay,
that's
but
like
to be fair, why we literally haven't used rhombi since like 3rd grade. Yeah, like I haven't looked at. I don't even think we talked about rhombuses in geometry.
A rhombus is a quadrilateral with all four sides are the same size. That's what a
Isn't that
rhombus is.
also what a parallelogram is?
No,
No!
parallelogram is
Well, a rhombus is a special type of parallelogram, but a parallelogram is a shape whose opposite sides are parallel. Or it's a
See, I never used that.
and whose opposite angles
It's like the
are.
man
Here, a parallelogram has two pairs of opposite parallel sides. A rhombus, the definition is just, so Caleb said a diamond, that's a good way to think of it. Four congruent sides. It turns out that if you do that, then with some simple geometry, you can show that, that actually has to be also a parallelogram. So if you drew a Venn diagram, you'd have,
every rhombus is a parallel.
here's all your quadrilaterals. Okay, here's all your quadrilaterals.
I would have these questions
In,
Like a square and a rectangle.
in that family of quadrilaterals, there are parallelograms, okay? And then in the family of parallelograms, sometimes you're a rectangle, and sometimes you're a rhombus. Guess what happens if you're a rectangle and a rhombus?
You're a
Square.
What?
And then over here,
Oh.
oh my goodness, over here,
Oh.
some trapezoids, trapping out the bando, and maybe some kites.
Kites are the
And those are
worst.
typically,
I agree.
and then
Interesting.
how about this like ectoplasm here? This sort of who lives in here? That would be your
A triangle with a
Wonkies.
dent in the bottom.
just
Wonky.
irregular.
Wonky. Wonky.
That almost looks like a trapezoid. Sorry. So just irregular, wonky quadrilaterals. Yes.
So I would have these questions on tests, and it's like, is this a parallelogram or a rhombus?
Yeah.
And I would always click rhombus, and they're like, no, that's a parallelogram. And then if I click parallelogram, no, it's a rhombus. But you said a rhombus is also a parallelogram.
The questions are probably asking, what's the most specific classification you can make? So,
Every
Well, I
rhombus
didn't
is a
have those
parallelogram, but
mighty
not every
things on it, so you
parallelogram
can-
is a
you can
rhombus.
tell.
for example, let's say I give you, if you're given this shape, that is guaranteed to be a parallelogram because the opposite sides are congruent. However, you cannot conclude that it's a rhombus. But if we give you this shape, and you say it's a rhombus, I'm sure if you said it's a rhombus and then parenthetically said, which BT dubs is also, it's a special case of a parallelogram, you're probably earning full credit for that one. Anyway, there's your,
Good job.
someone mentioned mammals. There's the same idea, right?
Yeah, the dolphins.
Oh, you could go, hey, look, here's all animals. Inside that subset of animals, there are mammals. And then you could be like a dog. And then like,
Yes.
here's your golden retriever.
Yeah, see,
Air
we,
Bud.
we do that with queer people and vampires.
But also.
Because there are all queer people, and
Dolphin.
then all vampires are queer, but not all
True.
queer people are vampires.
Right, so the dolphins would be a circle that doesn't intersect with the dogs, but is still inside the mammal side.
True, all vampires are queer.
Dogs.
So when
Of
they
course,
replace
you have
them-
it. You
I think that's just the manatee.
Oh, yes, I do.
What did they do to me? Why do they abuse me like this?
Oh, She-Hulk, we finished the problem now.
What?
This is, never mind. We finished the problem.
Yes. All right, guys. So
Bye.
let's go ahead and get to review some geometry there, because the answer to this question relies on a little bit of elementary geometry. Because this is a half a circle. Okay, we want the area that's trapped between the curve and the x-axis from 0 to 2. 2 just so happens to be the radius of the circle. Okay, so this is the area we want, right? Does everyone understand why that's the area we're looking for? Okay. What would be if you looked at the whole circle? Fuzzy Wuzzy was a bear. The area of a circle is pi r squared. So the whole circle.
That doesn't even matter.
I'm gonna always remember that.
The whole circle would have an area of pi r squared, but we just got a quarter of the circle. So what's the answer?
Fire squared over
1/4.
Pi.
A quarter of 4 pi is 1 pi.
But what about?
Yeah.
What?
Wait.
Well, again, so the whole circle, so a whole circle whose radius is 2 would have an area of 4 pi. So if you just want a quarter of that circle, you divide it by 4 to get 1 pi.
Just what?
No, come on, that's pretty good. That's one of the fanciest ways to write the number pi that you've ever seen. It's gotta be, right? There are a lot of fancy ways out there. Ramanujan famously had a whole bunch of weird,
I
wacky,
love ramen.
infinite, no.
That was good. Unproductive calculus class we've had in 2 weeks.
Have you guys all heard of Ramanujan?
No,
Really?
no, I don't care. You know, ramen does sound good.
I love
You know,
ramen.
Jeho, I didn't even know who
So
Harry
bad.
Styles was 2 weeks ago, so.
Harry Styles is just a pop star.
Thank
Ramanujan
you.
was one of the greatest minds, one of the greatest human minds that's ever existed.
Well, my point is, if I can't even recognize a pop star, how would I recognize somebody who was in history a long time ago? You'd probably actually be more likely to recognize it. I doubt it.
Whatever.
Always just like,
I'll say that.
fine, I don't care.
That's why.
Anyway,
I got a text.
last thing.
I dislike people.
You're probably gonna find the ones with the graphs, probably the easiest ones we do. Okay, so I'm gonna go over 1 or 2 examples of that. I have a really good feeling you're gonna go, oh, these are the nice, simple ones.
You have to graph 5.
5F. It's sort of.
Because I think you guys do it. By just
You-
doing 1/2 integral from 5 to 5
You,
times 2.
you can do that algebraically, but we haven't actually covered that technique yet. It would be the,
Can you just do can you just do U?
yeah, but then your u is raised to the -1 power.
Oh, wait, so you can't.
You got u to the 0. It's actually a special case. It would be a natural logarithm. We're gonna cover that later. But for now, just notice that 5f is an odd function, and graph a rough sketch of it, and then notice that the integral is symmetrical. So you're gonna have equal amounts of positive and negative area. Okay.
That's a good reason.
Ramanujan.
Okay, but, well, I'm not gonna ask now, but tell me later what this person did, but not right now. Because Ave will kill me. Yes, I will.
All right. So number 6. I'm sure you'll find this story very interesting.
Oh, yes. Very, very interesting. See, I like New John because I keep thinking Newton John.
Olivia
Olivia.
Newton-John, exactly.
Olivia.
Okay, so they give us a graph. This is a graph of y equals f of x. So they're giving us the graph and then asking us questions like, what's the integral from 0 to 3 of this function? Okay. Well, what's all you gotta do then?
You just have to add.
Okay, you just gotta go,
Not
well,
add. I'm like, what?
the true brute force way of this is to construct a piecewise function that represents this and then do it algebraically. But no, that would be craziness. You just go, just the area.
Gee.
So between 0 and 3, the area, the height is 2. So 3 times 2 divided by 2 is 3. How about if we go from 3 to 5? There's a moral. You might be thinking, why'd you put this easy question on here if that's all it is? There's some ideas here that I am attempting to get you to look at.
3 to 5.
The integral from 3 to 5 is how big? 2.
It's 2.
So then C asks us, what's the integral from 0 to 5? So can you maybe generalize that?
You can
Like-
add.
Is that only working out because it's this nice triangular looking shape?
Yes.
Or could I make some generalization like, here's some function f, and could I say that here's A, here's B, here's C? Could I say logically that the integral from A to B plus the integral from B to C is equivalent to the integral from A to C? Yeah, seems like that would, this area plus this area is equal to the whole area. So there you go, something to think about, some food for thought.
That is amazing.
Truly.
All right. Let's just leave it at that for now. If number 8, you'll notice you don't need to do 8 yet, but you'll notice it's kind of expanding on this. It's making it a little bit more doing stuff like, hey, here's a graph of f. What if you're asked about the integral of 2f? Or what if you're asked about the integral of f plus 2, that kind of thing. So
just get through 7.
get through 7. And thanks for the 100 bits, all that good stuff.